Okay, so for this question, it says psychiatrists wish to determine if there's a higher incidence of divorce among couples in which one of the spouses has suffered a serious head injury than among the general population. So, like if one of the spouses, the husband or wife, has a serious head injury, right? Serious head injury. Does that make them more likely to get divorced? We know head injuries can cause all kinds of problems in relationships and everything else. Now, people might have opinions, but what does the data say? That's what we're always into with stats. What does the data say? What does the statistical evidence say? Well, here's a study they did. This would be like a psychology study. Of the 47 couples who were married when one of the spouses had a serious head injury, 22 of them got divorced. That's almost half. Huh? Of the 53 randomly selected couples in which no head injury occurred, 17 have divorced. That's less than half. So it seems like it's less likely, but it's not a lot different. We'll see. All right. So anyway, so how are we going to do this? Well, it says it wants us to create a 95% confidence interval to estimate the true difference between divorce rates of couples in which a head injury has occurred and the general population, P1 minus P2, where population 1 is couples with injury and population 2 is general population, no injury. So where are we going to go? Let me show you where we're going to go with the online calculator. So if we go, here we go to the unit 4. We're talking two proportions on something. How did I know? Well, whenever they talk about, of the 47 couples, 22 are now divorced. Of the 53, 17 have divorced. They're giving you part, right? They're telling you what, 22 out of 47 are divorced. They're telling you what part of the group. That's always a proportion. That's what a proportion or a percentage is. It's what part of the group. So that's how we know. And why is it two proportions? Because there's two groups. There's those that had couples that had a head injury, or one of the two had a head injury, and couples were just normal, no head injury. So it's two proportions. So what do we do for two proportions? According to the uniform notes. Well, going to go to the online calculator, two proportions. That makes sense. That tells us what two hypothesis, but we're not doing a hypothesis. We're going to come down here for confidence interval. Fill in the CL as a decimal. Leave the radio button on not pooled. That's important. So we'll go there. So, okay. So when we go there, what we'll see, let me just write it right now for you. What we're going to see is, it says two proportions. It's going to basically say sample size and number of successes. Okay, and then over on the side it'll say first group, second group. Okay, and who are the first and second groups? Well, you just take them in the order in which they're mentioned in the word problem. What does it say? First comes among couples in which one of the spouses has suffered a serious head injury. So this is head injury than among the general population. So that'd be no head injury. So I just took them in the order they were in the sentence. You could also see right here. Population 1 is couples with injury. Population 2 is general population, no injury. Okay. So first off, we're going to have four numbers. What goes right here? This would be the first group's sample size. What's the sample size of the first group? Well, that's 47. 47 couples who were married when one of the two had a serious head injury. 22 are now divorced. So that's the successes, which sounds weird. Divorce is certainly not a success, but that's what we're measuring. So successes just means whatever you're measuring. In this case, we're trying to measure if they get divorced, right? That was the whole question. It says higher incident is there, if there is a higher incident of divorce among couples with the head injury. So 22 got divorced out of 47 among the head injury group. And then for the 53 with no head injury, 17 were divorced. So the 53 with no head injury, 17 divorced. This is the no head injury group. 53, 17 were divorced. So there's the numbers we're going to put in the calculator. Now you do have to also put in the confidence level, and that's right here, as a decimal. So 0.95. And then the radio button, you do have to leave the radio button not cooled. And we'll just say leave it. It's the way it already is. Just leave it be. Let's go back and do it. 2247. So I'm going to choose. Oh, where am I at? I'm getting confused. Oh no, I'm not. The calculator. There we go. Here's the calculator. Two proportions is number 19. Go to that. Number 19, two proportions. And it's going to go there kind of slowly. There it is. Okay, now we got to fill in. See this? I already forgot the numbers. Let's go back. What is it? It's so I'm looking right here. 2247. 2247. Let's do two at a time. 2247. So 2247. Back to this. What is this now? 1753. 53. Okay. And now we don't care about these radio buttons over there. We do, but we do care here. Pooled, not pooled. We just leave it on not pooled. And then put in the confidence level, it was 0.95, 95% confidence level. And see, calculate. Okay, we don't really care about the Z and the P. What we care about is the LB and the UB, lower bound, upper bound. That's our confidence interval. Lower bound, upper bound. There's our two numbers. Remember, we left it on not pooled. So there they are. Let's go back and see them. And that's exactly what they have right here. You just have to put them in a parentheses with a comma. Don't forget that first one's negative. Parentheses, comma in the middle. There's the two numbers. Now, what in the world does that mean? The final question is, according to your confidence interval, what does it mean? We have a 95%. With 95% confidence, the divorce rate, head injury is higher than the general population. Inconclusive or 95% divorce rate is lower. So how do you know? What does this mean? What does this mean? Well, that is actually fairly tricky. Let me show you what the answer is, and then I'll give you the logical reason why it is that way. So the answer is in the notes. So here it is. Here's the Unit 4 notes down here on number 4. This is where you want to look. And it tells you in the Unit 4 notes number 4, the meaning of a confidence interval for the difference, mu1 minus mu2, between two groups. And basically it says, look, if you get two negative numbers, all negative, 0 is not included, then you conclude that. If you get all positive, then you conclude that. If you get one negative, one positive, you conclude mu1 might equal mu2. So we have no confidence that are different, that mu1 and mu2 are different. They might be the same. That's basically no conclusion. Yeah, so that basically tells you. You just look right there. Let's go back to our case. What was our case? So our case, up here again. Back here. What was our confidence interval? Let me write it down here. Negative 0.043. I'm just grabbing this right here, bringing it down here. And then positive 0.337. Let's be really clear here. Notice this is negative and this is positive. What does it mean when you get a negative and then a positive? Back down to the notes. Negative, but some negative, some positive. What does that mean? 0 is included, implies it might equal 0. Thus, mu1 might equal mu2. So we have no confidence that they're different. They might be the same. We just don't know. So our conclusion is right here. Inconclusive. Our study is inconclusive. So that's how we answer. I just got that from the notes. Now, I know that probably is mysterious. You're like, well, why does one negative, one positive mean inconclusive? It's because if I just think, here's the reason why. If I subtract two numbers like 10 minus 7, that's going to come out positive 3 because the first is bigger, right? If the first number is bigger. Now, if you do it the other way and you go 7 minus 10, you're going to get -3 because the second, this was the first is bigger, the second is big. You get a negative answer. You get a positive answer. So basically, and you think, why are you subtracting things? Well, that's what we're doing in this problem. Remember, this is all about, it said create a 95% confidence interval for P1 minus P2. This is two proportions and their difference. The numbers that this confidence interval the calculator gave us, it's telling us what the difference is between P1 take away P2. And what is it saying? It's saying the difference is somewhere between negative 0.043 and positive number. So if I told you, hey, I'm thinking of a number, let me show you a number line here. Here's a 0 right here. It's somewhere between negative 0.0, oh, wait, hold on. Negative 0.043 and positive 0.337, right? It's somewhere in this region. That's what the calculator told us. When the calculator gave us a confidence interval between negative and positive, it's saying, hey, the real difference between these two. Remember in all these statistical tests, we're trying to get to what the real truth is. Like for all people, all couples who will ever have a head injury. What's the real truth about what a head injury does to a marriage? For all couples who will ever have a head injury. We're trying to figure it out by just using this little sample we took of only a few people. And so we don't know for sure. We're just saying, well, based on our sample, we are 95% confident that the real average, right? The divorce rate for couples is somewhere between negative 0.04 whatever and positive. It's somewhere in here. What does that mean? Well, that means it could be negative, it could be positive, it could be 0. We just don't know. If I told you, hey, I subtracted two numbers that came out positive, you know the first one's bigger. Subtract two numbers that came out negative, you know the second one's bigger. If I say, hey, I subtracted two numbers, it came out either positive or negative, or it might be 0. Well, then you just don't know. You just don't know whether the first number was bigger or the second number was bigger. Because if it was positive, the first number is bigger. If it was negative, the second number is bigger. We don't know. It goes from negative to positive. The answer could be anywhere from negative to positive. We just don't know. It's inconclusive. And so there we go.